Okay guys, in this video we have two word problems and we're going to sort of deal with what similar transformations look like in real life. And so we have a problem here. A map has a scale factor of 1 centimeter, so 1 centimeter on the map, to 500 meters in real life. So 1 centimeter on the map is representative of 500 meters in real life. So if a certain portion of the map is 2.3 centimeters long, how long is that same portion in real life? Okay, so we know that 1 centimeter divided by 500 meters, okay, and that's going to equal, that should be equal because it's a scale factor, it's being blown up, okay, that's going to equal 2.3 centimeters divided by x, or question mark, meters. Okay, so what we see here is that from 1 to 2.3, we know that that's been multiplied by 2.3. Okay, so to get x, we have to multiply 500 times 2.3. So we can do that up here. 500 times 2.3, okay, that's going to equal 0, 0, 15, and we have a 0 there, and 0, 0, 10. Okay, so that is going to equal, it looks like 1, 1, 5, 0, 0. So it looks like 1150. So that is 1150 meters in real life. So you can also write that, you know, if you know about kilometers, you can write that as 1.15 kilometers. So either answer is okay. All right, so this problem, we have a photo has dimensions of 4 by 6. So this is a common photo ratio. And so 4 inches by 6 inches. The photo has a scale factor. The photo is being blown up by a scale factor of 2 1/8 and is stretched to be 8.5 inches by question inches. Okay, we want to find what the length of this will be, or the height, right? So we talk about paper, we talk about sort of the width and the height. So 8.5 is the width, the height is going to be question mark, and we have to use this scale factor, right? Now the question then is, will the new photo fit on an 8.5 by 11 sheet of paper? So I know sometimes, you know, when you're on a computer, if you copy an image or something, and then you go to copy that into a Word document or into you know, a PowerPoint, something like that, then sometimes when you want to stretch the photo, you notice that the dimensions, hopefully, if you like things to look pretty, you don't want to make it so fat or so tall, right? But you want to stretch the dimensions from the diagonals, and sometimes that image does not exactly fit onto, you know, your paper exactly. So sometimes you have to make it a little bit smaller, or sometimes you have to sort of crop things out of your photo to get it in a ratio that you want. So this is sort of, you know, that sort of problem. So here we go. Let's see, our photo has dimensions 4 by 6. So, and there's a scale factor of 2 1/8. So 4 by 6, let me just write these down, 4 inches by 6 inches. Okay, and it's been, the scale factor is 2 1/8, so scale factor 2 1/8. Okay, so in other words, this number is going to be multiplied by 2 1/8. That's where we get the 8.5. So let's talk about the width. So the width here is the new width, I should say. Okay, so this is the original photo, Okay, now the new width is going to be 4 times 2 1/8, which is 8.5 inches. 4 inches by 2 1/8, okay? Now, we want to find out, that's given to us, so everything, I've just rewritten some information here. The new width. Now I want to find the new height. The new height. Okay, so this is going to equal, well, it's going to be, it looks like question mark times, or sorry, not question mark equals 6 times 2 1/8. Okay, so how do I solve this? Well, I want to make this, I want to change this form. It's easier for me to do 6 times, what is that, 17/8. So 17/8. Okay, and that's going to equal 6 times 17. If you don't know how to do, if you don't know what that is off the top of your head, that's okay. So 6 times 17 is 42. So it looks like 102. All right. So this is 102 over 8. All right. And so 102 over 8 inches is our question mark. All right. Now I want to put that into a normally in math we can leave things like this, but I would like to actually divide this, and actually I want to get this as a proper fraction. Okay, and so I want to see, is this less than, the question is this less than 11? Is it less than 11? Will it fit on an 8.5 by 11 sheet of paper? Okay, so let's go ahead and divide this out. Okay, so we have, let's see here, 102 divided by 8. So 102 divided by 8, well, 8 goes into 10 one time, so we get 8, that's 2 and 2. Okay, then we get 2, 8 goes into 22 twice, so we get 16 equals 6. 60. Okay, 8 goes into 60 7 times, I think. Okay, and that'll be 56. And we can keep going. We have 4, 0. You know, we can keep going on and on and on. But basically, we know that this is going to be 12.7 inches. Okay, so if we blow up a 4 by 6 photo and use a scale factor, if we're making the scale factor fit a sheet of paper for the width. Okay, so if we're taking a 4 by 6 and we're making the width be the same, then it looks like this will not, in fact, fit on an 8.5 by 11 sheet of paper. So you either have to, if you want to keep the same ratio, you might have to crop the picture, maybe take off 1.7 inches. Maybe there's parts of the picture you don't want, or you might have to make maybe not utilize all of your width in your photo. So this is problems, I think, maybe you don't sit here and mathematically think about these kind of things regularly, but I think this is something that students in the 21st century, certainly you've dealt with this problem of how to copy an image and then fit it into a format, whether it's for a paper, or PowerPoint or whatever that would be. So hopefully this gave you a little bit of an idea of how similar transformations exist in the real world, and you got a better idea of how they work. Thanks for watching.